In order to build a Turing machine, we only need 4 things: a machine table, a state register, tape, and a so-called head. The tape needs to be very long and divided into squares. The tape should actually be infinite, which makes the machine a practical impossibility, but we don't need to worry about that here. The head needs to be capable of performing these 4 tasks. 1. Interpret the symbol within each given square on the tape. 2. Switch symbol within squares. 3. Move between squares. Halt or stop all activities. That's it. And then we have the state register. The only thing it's doing is really storing the state of the machine. Don't worry, it'll all make sense soon. And lastly, the machine table is specifying the rules which the head acts upon. So here we have the full machine, and I've provided a tape with a specific sequence of 1s and 0s. So let's start the machine and I'll explain what occurs. The machine begins within the first state, which tells the machine to follow these 2 rules. If the head reads 1, then change nothing and move to the right and change to state 2. And secondly, the rule of if the head reads 0, then change nothing and move to the right and remain within the first state. So in the first couple of squares, the head only reads 0s, which causes the head to continue to the right and neither change the symbol nor the state. But here it interprets a 1, which causes the machine to not only continue to the right, but also swap state, which means that it will follow a new set of rules, which are if 1, then change nothing and move to the right and remain within state 2, and the rule of if 0, then change the 0 to a 1 and move to the left and switch to state 3. The machine moves on until it reaches the next 0, which causes the machine to swap the symbol and change it into the third state. The rules of the third state is if 1, then change nothing and move to the left and remain within state 3, and the rule of if the head reads 0, then no change and move to the right and switch to state 4. The head continues to the left until it reaches the next 0, which causes the machine to move to the right and enter the fourth state, which gives the head the instruction, change symbol and then halt. Now let's look at the tape. In the beginning, the tape looked like this, but now it looks like this. You might realize that what the machine has actually done is calculating 2 plus 3. And as you can see on the new tape, we find a set of 5 1s. Now, this was a very basic example of computation, but what's amazing about this machine is that it is basically doing math, right? And in principle, a Turing machine is capable of performing all the tasks of a modern computer, provided that the tape is long enough. Now, the thing with the Turing machine is that it is being rational, a trait that before was thought of to be uniquely human. For instance, Aristotle claimed that the defining feature of humans was rationality. But a Turing machine is rational, isn't it?